Alright, we are going to be taking our Unit 3 test very soon, and so to start reviewing for it, we have to go all the way back to the beginning of the unit, where we looked at domain, range, and what makes something a function. So on this sheet, we're going to look at a review of those three topics, of domain, of range, and how to be a function. Domain are our x values. And so to be a function, the x values cannot repeat. The y values can, x cannot. When we have a discrete relationship, like these first three examples, that is when we just have a few points and those points are not connected. So when we list the domain and the range, all we do is we list those numbers from smallest to largest. So for this first example, my domain would be these x values, so -3, 1, 0, 1, and 5. We list them from smallest to largest, and the other thing is we do not repeat. So if a number happens more than one time, we still only list it once. My smallest number in the domain is -3. Then we have 0. And then we have 1, which shows up 2 times. We only put it one time. We don't have to list it both times. And then 5. Our range, we do the same thing, but now with the y values. So we have 3, 1, -2, -4, -1. None of these repeat, so we have to list them all. And we go from smallest to largest. So the smallest is -4. Then -3, -1, and then 1 and 3. And in order to be a function, our x values all have to be different, but because we have 1 in our domain twice, this is not a function. So we just put no. If we have the same thing with points, but they're listed in the mapping, our domain is all the x values, and in mapping we already have them from smallest to largest, so we just list them out. 3, 6, 12, 18. The range is the y values, so 5, 7, 9, and 10. And then to be a function, each x can only happen once. And right here, since 6 maps onto 2 different numbers, it maps onto 5, and it maps onto 10. This is also not a function. And then if we have coordinates, like in this next example, all right, if we have coordinates, we're going from smallest to largest. So for domain, we start here at the left. That is at -1. And moving on, our next point is here, which happens at 1. The next one is here, which is at 2. And then our biggest value in the domain is here at 4. For our range, we're going to start again with our smallest, which means the bottom. We go as far down as we can. So our smallest value in our range would be these 2 points at -2. And again, we just list it once. Then going up, our next number is at 1. And then the last one is here at 3. To be a function, our x values cannot repeat. And so since all 4 of these x values are different, this is a function. So that's how we list them with discrete functions. It's just going to be a series of a couple of numbers from smallest to largest. Domain is your x, range is your y, and to be a function, our x values cannot repeat. When we have graphs that are continuous, where all the points are connected, domain and range are going to be inequalities because it includes every point in between those numbers, and so there's infinite points, we can't list them out. So we just list them as an inequality. But we still have to do the same thing. We're still going from smallest to largest. So for our domain, we go as far left as we can. For this first example, there's an arrow here that's pointing to the left forever, which means there is no smallest x value, it just keeps going. That means there's no starting point. If I go to the right, there's also an arrow, which means there is no ending point. So our domain for that one is all real numbers. For our range, we do the same thing. So I start by looking down on the graph, and there is no lowest point. This arrow, it keeps going down forever, so there's no lowest point on the graph. It also keeps going up forever, so there's no highest point. So our range is also all real numbers. And to decide if it's a function, we just look. As long as each value is only there once, when I draw that vertical line, I only hit the graph one time. Yes, it's a function. For something like this next example, where we have a circle, we do have starting and stopping points. So for my domain, I go as far left as I can. The furthest left point is right here, and that is at -3. The farthest right we go is here at +3. Domain is our x value, and that domain is any number in between those. So we're going to draw less than or equal to signs. All right, this means that x is any number from -3 to +3, anything in between there. We're going to do the same thing for the y's. So as far down as we can go, which is right here at -4. The farthest up we go is here at +4. Range are the y values, and then same thing. Y has to be in between those, so we're going to make those less than or equal to symbols. And then to be a function, it has to pass the vertical line test. But in this case, if I draw a line from one part to another, I'm going to hit the graph more than one time. We end up hitting the graph twice, and so this is not a function. And then sometimes, so in this first example, we had no starting point, no stopping point. In the second one, there was a starting and a stopping point. Sometimes we have examples where there is a starting point but no ending point, or it might be the opposite. There's no starting, or there's no ending point, but we know where it starts. So for this example, for our domain, going as far left as I can, there's this arrow here that's pointing left forever, means we don't have a starting point. This arrow here is going right forever, that means there's no stopping point. So our domain is all real numbers. For our range, going down, there is a starting point. This is as far down as our graph goes, and that happens at -1. Now, if it was pointing down, that would mean our y has to be smaller than -1, but since these arrows are pointing up forever, that means that -1 is the smallest our number will get, and then it keeps getting bigger and bigger from there. And so our inequality sign is going to say that y has to be greater than -1. Any number bigger than -1 and including -1. This point here, even though it looks like the highest point, because of the arrows, it's not. These keep going and it goes higher than that point is. And then to decide if it's a function, we just look at that vertical line test, and since no matter where we look, we only hit the graph once, this is a function. So that's what we're going to be reviewing today: domain, range, and telling if it's a function. Tomorrow we'll review how to graph real-world scenarios and how to graph functions by filling in tables. And then the final day of review, we'll look at function notation and looking at the zeros of functions.